Hey guys, I am getting a couple of questions already about the homework, which is understandable. We ran short on time with us trying our first actual lesson on this device, or me trying my first lesson on the devices. It's timing won't be perfect. All right, that said, the two questions that I foresee you guys having relate to questions similar to what I am going to show you here. So hopefully this is enough to help you along the way. Hopefully you have a question that's somewhat like this. I know that. And you should be able to see my OneNote. That's the diagram that I'm using. Yours will be different, right? So there's three charged particles in a line, so it's one-dimensional. And ultimately, in this one, I'm being asked, find the net force that's on the charge on the right. So this charge over here. So the first thing you want to do is kind of sketch out a picture of what that charge has going on as far as forces. So it has interactions with two other objects, and based on Coulomb's law, we have that the electrical force is K, one of the Q's, in this case we'll say Q1, the other Q, Q3, that's the one in question that we're looking at. And so this is going to look for the interaction between the outside forces, the outside charges. Those outside charges are going to cause Q3 to be repelled to the right, right? Because it's a negative charge. It's a negative. It has a negative on the other side, so it wants to be repelled, like charges repel. Okay, so let's call this force the force on charge 3 coming from charge 1. And in order to figure that one out, we just plug in the numbers that match it. So F31 is equal to K, 9 times 10 to the 9th. That's Newton meters squared per Coulomb squared. That's the constant, K. Times charge Q1, which is 8 times 10 to the negative 6 coulombs. And then we got charge Q3, 4 times 10 to the negative 6 coulombs, because microcoulombs are negative 6, all over the distance between them, which in this case is 0.5 meters squared. When we do this, we end up with, if my math is right here, hang on a second. Yeah, get 1.152 newtons. And is it positive or is it negative? Well, I drew this arrow on the diagram over here. This arrow is indicating that it's to the right. So I'm going to add a plus sign because it's to the right. For F on 3 coming from 2, we're going to do a similar calculation. The only difference, instead of the 8 microcoulomb, we're going to have a 3 microcoulomb. Notice I'm definitely not putting signs in for pluses and minuses here. I've already accounted for the directions when I draw my arrows on here. Oh, by the way, Q3, how's it going to be forced by Q2? Well, they're opposite charges, so Q3 is going to want to be attracted to the left. So I'm going to draw an arrow to the left called F13 from 2. And then we got to list Q3's charge, and the distance between them is 0.2 meters squared. And when we work this one out, we end up finding out that Q, or force 32, is equal to 2.7 newtons. That's going to be a negative. It's negative because it's to the left. That's what we said it was going to do, because it's going to be attracted to Q2. So then we'd sum those forces, and that's what the question's asking, is find the sum of the forces on 3, right? The net electrostatic force. So we're going to add those together. And we end up with a negative 1.1. Oh, no, it's not. Negative 1.548. That is the net force.